Okay. So let's see how things went over here. Now, again, I don't always like how they want you to kind of fill things in, but I think it's helpful at the beginning. And hopefully you might see things a little bit differently, but we're just trying to fill things in as we go. So PR is congruent to QS. Everybody should be able to tell me that's what. All right, I'm pretty happy with you on that. All right, why is PR equal to QS? Right, okay, definition of congruence. I'm happy with that. Why does PQ plus QR equal PR? Yeah, segment addition postulate. All right, now before we go any further, I'm just kind of looking at this. We're trying to prove that PQ is congruent to RS. That's what we're trying to prove. Given that PR is equal to QS. Now, can everybody see that's just obvious, right? Because if PQ, if PR is congruent to QS, they both share what? They both share QR, right? So the other parts have to be congruent, right? That's what I'm hoping you can learn from this is, to me, before I write the proof, I just say, can I see that that's even true? If I can't see that it's true, then it makes the proof harder. But if I can look at it and say, okay, I'm agreeing that is definitely true. If you can see that, then you can write the proof for the most part. All right. So because of that, all right, D was segment addition postulate. What's that going to be?
QR plus RS equals QS.
QR plus RS equals QS. All right. Now, again, I'm hoping you're just not filling this in. All right. That's what I'm hoping. I'm hoping you tried. All right. And that, again, is the segment addition postulate. What? All right. What is the next one? Okay. So I'm not sure. All right. So I'm looking at this piece right here. And I'm looking at this piece. Now, to me, sometimes I believe I organize mine a little better than the book does because I like to just go from what's different from D to E. All right. But I don't think that's what they're doing, correct? They're taking which statement? Which statement are they taking, David? Good. Yeah, they are definitely using C. What else are they using? Anybody else want to tell me? They're using what?
D.
Yeah, they're using D also. But they're using C and D with which one, though?
B or B?
Definitely B. All right, so I think that's harder. All right, so tell me what I'm seeing. Does everybody see PR is congruent to QS, right? So this right here is going in here. Does everybody agree with that? And that's this piece right here. Yes? And then, hold on a second. This PR is this PR, correct? So I'm replacing the red PR with what? I'm replacing that. All right, now again, I'm not trying to, like some of you hopefully going, yeah, I can see that. I'm going slow for those of you guys who might be a little questionable and you just sit there and not asking me questions. That's who I'm targeting right now. All right. So if you guys are like, wow, this is just so simple. Why are we wasting so much time? I wish you would just say something, right? If you don't communicate with me, I can't tell what you're doing. All right. And this is difficult. I understand that. All right. So if you don't tell me you're good or bad, or you just sit there and writing down things, it's not helpful for me. All right. I want to make sure you know. All right. So I'm looking, is everybody okay? Looking at B, I'm going from B to what? Nope. I'm going from B to what? E using what? C and D. All right, is everybody with me on that now? I'm going from B to E using C and D. Is everybody with me on that? All right. When I'm writing the proofs, though, I like to just go directly from B to C and from C directly to D and you'll see how I'm going to do a little differently. All right. But with that being said, does everybody understand this is the red, right? Then I'll change colors here just to make sure. This QS is going to be the what? This QS, which is what? There you go, which is that. All right, now is everybody seeing that? All right, hopefully. And we can just call that a what? We can call that a substitution. We can call that a substitution. All right, now again, I'm just telling you, as we go, it gets harder. All right. So I really want you to see it. I just don't want you writing things down because it's going to be a blur if you're just writing it down. Everybody's good with that? All right. Now, of course, we're just subtracting what? QR, right? So now that was kind of easy. We can say what? PQ equals RS. And then we say what? PQ is congruent to what? RS. All right, that is pretty formal. All right, now let me just say something else too, because again, this is kind of annoying and it's just technical things. All right, being technical. All right, I'm not as technical for you because again, in the grand scheme of things, it's not really that important, but I would like to point this out. Equals is referring to lengths, right? Congruence is referring to segments. Hopefully that makes sense, right? So when you say PQ is equal to RS, that's referring to the lengths. PQ is congruent to RS is referring to the what? The segments, all right? Small technicality. And if you leave PQ equals RS out by mistake, do I really care? I don't really care, but I just want you to see that. All right, is everybody happy with that? All right. If you were able to do that, I'm pretty happy. You actually are right where you should be. All right. So let's knock out number 5 now. All right. Well, actually, let's knock out these. Why is QA congruent to QA? That is the reflexive property. And does everybody know I gave you those properties, right? You can just look at them. If AB is equal to BC and BC is equal to CE, then AB is congruent, I should have said. AB is congruent to CE. That's the what, guys? Whoa, 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 whoa. Transitive property. If you said what, though? I wouldn't be mad. All right, but this is the transitive property because it's in the right order. AB is congruent to BC, then BC is congruent to CE, therefore AB is congruent to CE. Number 3. Come on, everybody should be able to say that easily now. Hello. Number 3, what is that? If Q is between P and R, say it again. Yes, sir. Thank you very much. Segment, addition, postulates. Right? If you can't see that, you can tell me. All right, number 4. What is this? AB plus BC. AB plus BC. Then AC is being replaced with what? Is that true? And that's a what? Yeah, we could say that's a substitution. All right. So hopefully you're able to name those. That wasn't a big deal. All right, then I think I asked you just to try 5, correct? No, I didn't. Okay, good, good. All right. So now I want to sit with you guys really and hammer out 5, 6, 7, 8 in class. All right. And let's try to get this done carefully with everyone participating. And I'm just begging you not to sit there and not do something. All right. If you're not doing it, if you're not trying it, I'm telling you, when you get to the test and I put 8 proofs on the test and you got to do 8 proofs, it's not easy. All right. It's just not. And that's all that's on the test is the proofs. All right. So you've got to try. Here you go. Uh-oh. Somebody used them all. Sorry about that. Oh, yeah. There's more over there. Good shot. All right. Here we go. Thank you. All right. Let's knock out 5 now. All right. Of course, everybody has what? Given. I'm happy. All right. Come on now. Everybody's responding. So now what's true? What's B? Say it again. Come on, loud. Yes, I would just go ahead and say SU equals LR. And I would say what? TU is equal to what? LN. All right. Now notice it seems to me like they're now doing what I want to do, which is just list. Let me see if they listed. Yeah, they just list all the givens first. All right. All right. Someone else. Carter, thank you. Is everybody happy with that? ST plus TU must equal SU. LR must be LN plus NR. Segment, addition, postulate. Okay, we're on the right track. All right, now the hard part, trying to figure out how they went from C to D. Go ahead, David. But you got to tell me how. Hold on. I like that. So this SU is becoming what? And then this LR is becoming, yes. All right. I don't think that's bad. All right. That's a substitution. All right. All right. Now, what am I doing with E? Cooper. Okay. So show me where I'm going from. What step?
B.
All right. B. I'm going from TU, right? And then where does it say what TU is?
It says T is equal to LN.
All right. So, oh, okay. I see. Good job. All right. See, this TU is that TU, correct? And I'm replacing that TU with what? LN. Is there anything different? There's nothing different. Right? You have to hunt for that. Does everybody agree? So that's a what again? Yeah, I'm a substitution. All right, hold on. And at any time, speak up. Go, tell me. Yes, exactly correct. All right. Now, I want to say something here because, again, on your test, when you're going to do it on your own, right? I don't like this filling stuff in. I like to do it myself. All right. But I do think this is important for us. So we're going to say, what did you say that was? Yeah, subtraction property of equality. All right. Now, for me, I'm probably going to listen, and you see if you're agreeing with me. I'm probably going to leave. I'm probably going to leave this step out. And I'm just going to probably write what? ST is equal to what? NR by what? No. Well, I'm just saying I'm not using a substitution. I'm just going to say ST is congruent to NR by the what? Subtraction property of equality, right? So now I'm trying to show you some geometry books are a little bit different because they want you to write that whole thing out. All right, so I don't want to confuse anybody, so I hope you're listening to me. All right, why is this? That's perfect, what she said. But why would we be calling ST equals NR a substitution property? Can anybody tell me what was being substituted there? That's why I don't really think it's necessary. Yes, exactly. Exactly. That's why I think it's kind of silly. Ln minus Ln is what? 0. So we're substituting in zeros for Ln minus Ln. And we're substituting in Ln minus Ln what again? 0. But to me, that's just silliness. All right. So I'm not doing that. All right. I'm going from here, right? Which I'm trying to give you the green light, guys. So I'm hopefully you're hearing me. Do I really care about this step right here? No, that's out the window for me. I'm just going to put ST equals NR by what? Subtraction property of equality and be done. Does everybody hear me on that? And then the next one is what? Definition of what? Yeah, definition of congruence. So definition of congruence is to go from congruent to what? Equal, or from equal to congruent. All right, or from equal to congruent. All right, that's kind of annoying, but hopefully you're saying that's not really that hard. All right, and as you do them, you will get what? Better if you are actually what? Trying them. All right, you're trying not to just put in my answers. All right, you're trying not to put in my answers. All right, so let's knock out number 6. Let's see how good we are. All right. Oh, yeah, I don't really care for this so much either. This is silliness. All right, I almost just got rid of this. But so what we're trying to do now is we're trying to prove what? This is a what? The symmetric property of congruence is kind of what we're doing, right? And to prove the symmetric property of congruence, we're going to put them to what? Equals. Because we know the symmetric property of what? Equality is true. So we're going to use the symmetric property of equality to prove this. All right. So again, this is kind of silly. And again, I used to just argue all the time. I already know this. This is common sense, right? But mathematicians want to prove everything. We're just not allowed to say things are true. All right. Well, all right. Let's see if this makes sense. So we know what? Thank you, whoever said that. AB is congruent to CD. So now why is AB equal to CD? Definition of what? Congruence. Now, why is CD equal to AB? Yes, thank you very much, guys. I shouldn't have said it. Symmetric property of what? Equality, not of congruence. Symmetric property of equality, right? And so now we can say that CD is what? CD is congruent to AB by what? Definition of congruence. All right, I just think that's easy. All right, and unnecessary. Easy and unnecessary because it was what? Common sense. All right, so, wow. All right, here we go. Now I kind of just wrote a bunch of stuff out here trying to see how this worked. All right. AB is congruent to DE. B is the midpoint of AC. E is the midpoint of DF. All right. All of that is what? Yeah, I don't know what that's there for. I think I just messed this up when I was writing it. All that is the given. All right. So once again, if you don't know this one, you haven't been paying attention. What? Definition of, yep, thank you. Definition of congruence. So what's true if B is the midpoint of AC? Tell me. You're amazing. AB equals BC. All right, now there's two lines there, probably for another thing we should write. Someone else jump in. What? Yes. DE equals EF. And we learned that from the what? Definition of midpoint. We learned that from the definition of midpoint. Okay, so come on now. Why is BC equal to DE? Well, if that's true, then you should be able to see somewhere that DE is equal to BC. Does it say DE is equal to BC? So that's okay. Sophia, what? Show me why, though. Tell me how I'm getting that. See, that's to me the hardest thing to see, right? So I need everybody to help everyone else who may not be seeing it. What are you looking at? Tell me. You explain. Hold up. Where's that at? Line C. She's saying, I'm looking here. AB is equal to BC.
And AB is equal to DE.
So now I'm looking that AB is equal to DE. So what?
And BC is equal to DE.
So what did I do to get that? I replaced what? What did I replace? Come on. Yes. Hold on a second now. I want to make sure I'm right. So again, I know it's tricky. That's why I'm going slow. And some of you are like, this is so dumb. It's so easy, right? But I'm trying to make sure everybody's seeing, right? I'm using line B and C. Do we agree with that? Is that what you're telling me, right? And I'm looking here. And I'm noticing this is almost the same. DE and DE are the same, correct? But AB became what? Because why? AB is equal to BC. I replaced AB with BC. All right. That's what you have to go through and hunt and find. It's not always easy. All right. So that's definitely a substitution. All right. Now that's how I want someone else to tell me now. Someone else jump in. All right. Go. Thank you. But you're going to have to tell me why. So hold on. I believe you. So now what lines am I using? I'm using C with what? I'm using C with DE equals EF. Is that what you just said? So which one is being replaced? Hold on a minute. Now I'm looking here, right? B, C, and EF, right? Now I'm looking here, right? So DE is being replaced with what?
Yeah.
DE is being replaced with EF. Oh, you're telling me from these two, right? Okay. See, this is what I'm telling you. This is what I'm saying. All right. Tell me again what you're saying in slow, because I lost my train of thought. What were you doing? DE right here gets replaced with EF. Beautiful. That's correct. Now I'm seeing your thoughts. Right? There you have it. Anybody have any issue with that? All right, so I'm happy with that. That's a substitution. All right, now what? I'm listening. BC is congruent to EF, and that's what? Definition of congruence. Now, is everybody aware that the first one is always what? The given, and the last one is always the what? Proving statement, right? So there you have it. And that again was definition of congruence. Now, listen, is there other ways of seeing that? And I'm saying, yes, there's other ways of seeing that. All right. That's why personally I hate doing this, because I can't always see what they're trying to show me. That's why when I'm asking you, I'm literally trying to figure out what he's saying. All right, because sometimes I don't see it that way. All right, is everybody good with that? All right, I'm happy with you. All right, now look. Number 8 is how I like it. All right, like a blank slate. You have to do it on your own. All right. So let's do this. Let's pause the video for 5 minutes. Try there on your own. See if you can do it all on your own. All right, give you 5 minutes. All right, and then that'll be it for today. Setting the. All right, so what I honestly want to do is instead of trying to rush through it, what I want to do is I want us to kind of just stop here for a second. All right, and we're just going to leave this one for homework. All right. And so now that you've worked on it for 2 or 3 or 4 minutes, and listen, guys, I totally understand. If you're clueless, trust me, I understand. All right, I don't want you to feel bad about it. All right. I want you to, now that we have 3 or 4 more minutes left, is try to sit somebody, or you can ask if you want to double check and see if you're heading the right direction. But listen, if you feel like you're good, all right, then just finish it up. If you feel like you're kind of lost, right, see if someone wants to show you something. All right. But there is a lot of value in trying on your own. All right. So with that being said, we're going to end, and you guys will just put this up on the board tomorrow, first thing. Good job today, guys. Very good.